Hello and welcome to SudoKanard. In this video I'll be solving a puzzle set by myself and it's called All or Nothing Killer Sudoku, and I should add Tetris Edition. So what it is all about? It's all about Killer Sudoku, meaning that on top of the usual Sudoku rules you have cages with a dashed outline. In each of those cages, all digits must be different. Well, in most cages, this is no real constraint, but on this one, this is a constraint. This digit must be different from this one, and same in this one. For some of the cages, there's a number on the top left corner, which is the sum of all digits. And there's an additional rule for this puzzle, which was invented by my good friend Erwan de la Motte-Beuvron. And this constraint is that for each sum, either all digits of this number are in the cage, in this case 2 and 3 would have to be in the cage, or none of them is in the cage. So there shouldn't be 2 nor 3 in this cage. And that's the set of rules. And I'd like to thank Codec, who helped me improve the puzzle. Now, let's start solving this. Well, the first thing you should notice is that a clue with a 0 in the number obviously doesn't have a 0 in it, so 2 can't be in it either. And actually, in any 20 cage, if it's made of 4 digits, then it is impossible to have the digits inside. And why is it the case? Because say it is the case, take 21 or 27. If you assume that the digits are in and you remove the 7, or here you remove the 1, if you remove the unit digit, then you get 20. And once you remove the 2, you get 18, but 18 with 2 remaining digits is impossible. You should have 9 plus 9, which is not allowed. So 2 can't appear in them, and the other digits can't appear either. So knowing that, there's no 2 in here, there's no 2 in here, there's no 2 in here, and 2 has to go here on this row. Oh, it's blue pen. I usually do it in black, but let's stick to blue for this one. Next, 26 and 27 are really restricted, because if you take a list of all decompositions of those numbers as a sum of 4 digits, you'll see that only one doesn't include a 6 for 26 and only one does not include a 7 for 27. I just draw the list. For 26 you have 9, 8, 7, 2. This one has a 2 but not a 6. 9, 8, 6 and 3. This one has a 6 but not a 2. 9, 8, 5 and 4. This one this one respects the rule. How should I say? The rules are verified by this one. And then there's 9, 6, 7, 6 and 5, and this one, no, sorry, and 4. And this one has a 6 but not a 2. So only 9, 8, 5 and 4 is a valid decomposition for this 26. The same way, 27, 9, 8, 7 and 3, not allowed. 9, 8, 6 and 4, this one is valid. 9, 7, 6, 5, this one has a 7 but not a 2. So only 9, 8, 6, 4 is a valid decomposition for 27. And using this quadruple, we know that only 6 can go in this cell, and 4, 8, 9 in the other 3 cells. Now let's have a look at 16. We know it doesn't include a 2. Could it not have a 1? If it doesn't have a 1, then the minimum sum we can obtain with 4 digits is 18. But 18 is too much, so there has to be a 1 in here. And we know that together with a 1, it has to contain a 6. So this 16 should be 1 plus 6 plus 2 digits adding up to 9. Without using 1, so it can't be 1 or 8, it can't be 2 or plus 7, it can't be 3 plus 6, it has to be 5 plus 4. So those 4 digits are 1, 6, 4, and 5. So there's no 5 in here, there's no 4 in here, this is a 4. Now 4 and 6 can't go there, they have to go there. And 1 and 5 go in those cells. 3 and 7 remain in the 3 by 3 block. Let's have a look at this row. We already have 3 digits adding up to 19, plus 21, that's 40. We need another 5. 5 with those 2 cells, not using the 2, they must be 1 and 4. These 2 cells now must add up to 15. This can't be a 6, this can't be a 7. There are only 2 possibilities, 9 plus 6, 8 plus 7, in this precise order. And those cells are, those digits are 3, 5, 6, and 7 in some order. Let's have a look at this 18. We know that 18 must either contain 1 and 8 or none of them. But we know that those 2 digits, 4 and 6, are not in there. And together, those digits plus those digits make a total of 28. So the remaining 3 digits must have a sum of 17. If 1 and 8 are not in there, then 1 and 8 must be out in those 3 cells. So there must be 1 here, 8 here, and to complete to 17, we should have a repeated 8 here, which is not possible. So 1 and 8 are both in this cage. So this is a 5, this is a 1. So this 18 cage has 1 and 8, and the other 2 digits add up to 9 without using 1, 4, or 6. They have to be 2 and 7. These are 1, 8, 2, and 7. So this is a 9, this is a 6, and this last digit is a 3. No 1 in those 2 cells, they must be 2, 7, and 8. By Sudoku, 3 goes there, and 5, 6, 7 remain to fulfill this 21 sum. And we can check that 2 and 1 do not appear. No 7 in here, so there must be 1, 2, 8 in some order. Now let's have a look at this. We don't know the sum, but the rule still applies. What are the possible sums? Well, the missing digits in second row are 4, 2, 4, 5, 8, and 9, adding up to 28. And one of those digits is not in here. if we remove 5, 4, or 8, we get 20 something. But if we remove those, we keep the 2. And we already noticed that a 20 something cage should, well, it shouldn't contain a 2. So it's impossible to remove 4, 5, or 8. And it's impossible to remove the 9 because 9 on this row does not go there, 9 goes there. So all those 4 digits must be in the cage and 2 has to go here. Now we have here a 5 and 4, 8, 9 in the remaining cells, making this a total of 26. And that's the correct sum. That's the correct decomposition, as it was the case here. Next step, let's have a look at column 9. There should be a 2 and a 3 in column 9, but they can't go in the 23 sum, so they have to go in those cells. The remaining 2 cells must contain digits which are either 7 and 8 or 7 and 9. Now let's have a look at what goes in the other 2 cells. First case, we put 7 and 8 in those cells, which makes 15. Those cells should add up to 8. 8 would be with 1 or 7. No, 7 is already used. 2 plus 6, but no, there's no 2 in this cage. 3 plus 5, no, there's no 3 in this cage either. So 7 plus 8 is impossible. It has to be 7 and 9. 9 is not in this cell, 8 is not in this cell. Now that's 16. Those cells must add up to 7 without using the 2 or the 3, so it has to be 1 plus 6. And this is a 4, that's a 6. And this is better. What next? Next, what is possible for a 25 cage? There was only one option for 26 and only one option for 27. Let's have a look at 25 without using a 2 nor a 5. So 9, 8, 7, 1 looks possible. 9, 8, 6 and 3 looks possible. 9, 8, 5 and 4, not possible, there's a 5, there's no 2. 9, 7, 6 and 3 looks possible. 9, 7, 5 and 4 looks possible. Oh, but there's something I have to note later. Oh, I've forgotten to do something first. I'll do it at some point. No, I should do it now. Or no, this one is not possible. Let's finish this. And with 9, there are the only possibilities, and with 8, there's 1, 7, 6, 4, which looks possible. Well, this was, no, this is, what is this? Oh, that's a 2. Oh, I did it wrong, sorry. So with a 2 but no 5, that's not possible. 9, 8, 5, 3 is not possible. Now, sorry about this. 9, 7, that's 16. With 9, it would be 6 and 3. This one is possible. 9, 7, 5 and 4. This one is not possible. And then there's 8, 7, 6 and 4. So there are 3 options for this 25. And obviously, if you use a list of all decompositions, you can find about this much faster. Now we'll see that not so many are available actually. Let's have a look at this 16. And then we have some restrictions on those. Yes. So what about 16? If it contains 1 and 6, then the other 2 digits must add up to 9, and in the same fashion as what we had this, no, there are 2 options. But we can't use the 4, so it won't be 4 plus 5, so it will be 2 plus 7, and that's the only way. So this is 1 or 7, 1, 6, 7, and 2 somewhere in this. Let's have a look at this row. We already have 5 digits. The remaining 4 digits must be 1, 2, 3, and 7. So this is 1, 3, or 7, making this a 1, 3, 7 triple. And now by Sudoku, this is a 9. And those digits must be 4, 5, and 8. And 5 is not allowed in the 25 sum. So knowing this option is no longer available. It does not contain a 4 or an 8. And this is a 2 or a 3. And now you can see that 5 and 8 are not in this cell, so they must be in one of those cells. Okay, so now this can't be a 1, so it has to be 2, 3, or 7. And those cells must be 1, 2, 3, or 7. This is 1, 2, or 7 as well. Now, what is the next step? Let's have a look at where 3s can go. There's no 3 in there. And there's no 3 in here. There's no 3 in here, so there has to be a 3 in one of those cells. And what else can we say? So there's no 3 in this 18 cage. What happens if we use 1 and 8? If we use 1 and 8 in here, we need another 9 to fulfill the 18 sum. We can't use 3, so we can't use 6. But we can have 1, 2, 1, 8, 2, and 7. We can have 1, 8, 4, and 5. And what if there is no 1 in this cage without using a 3? So there has to be a 2, because if there were no 1, 2, or 3, the remaining digits would be much too big for an 18 sum. So there has to be a 2. No 3, so it makes 4. And we need another 12, which can only be 5 or 7. And you see that any option remaining does not include a 6. So there is no 6 in this 18 cage. So there has to be a 6 in one of those cells, not in here. But so in one of those cells there has to be a 6. So it has to have a 6 on the last row. Knowing this, there is no 6 in this 25 cage. So this 8 7, 6, and 4 option is removed, and only this remains. So this is an 8, and the other digits are 1, 7, and 9. Well, this was definitely the trickier part of the puzzle, I think. And now we have a 1, 7, 9 triple, so this can't be, so there has to be a 1 in one of those cells. This can't be a 1, and that's a 6, that's a 1. And this one combined with this one says that there is a 1 in one of those cells, so this possibility is not a possibility. So there's a 1 in here, and 1 doesn't go here, so there's an 8 in here as well. And this can't be a 7, so it has to be either 2, 4, or 5. What next? What is the next step? Oh. So we know there's 1, 2, 6, and 7. So there has to be a 3 in here. It goes there. And there has to be a 9 and one digit between 5 and 8. So this is 5, 8, or 9. On this row, this is 2 or 4. And let's have a look at those. 9, 8, 5, and 4. This is 5, 4, 5, or 8. There's a 9 here, so this is also 5, 4, 5, or 8. This is 4, 8, or 9. And this one is one of those. This is not a 3, so it has to be 1, 2, or 7. And now there's a 2 in one of those. Well, no, sorry. No, there's a 3 in one of those. So this is a 2. That's a 3. That's a 2. There's no 2 in here. And now there's no 2 in here, so one of those has to be a 2. That's it. That's the correct order of deduction. There's a 3 in one of those cells, and a 3 in one of those. And a 2 in one of those. Now, where do we look? This 24 cell, this 24 cage, should be restricted. Oh, I've erased what happens in here. Well, that's 1, 8, 2, 7, or 1, 8, 4, and 5. Okay. So 8 is in here, so there's an 8 here or there. Now let's have a look at this 24 cage. There's a 3 in there, so the remaining 3 digits should add up to 21. 9, 8, and 4 is not an option because we would have a 4 and not a 2. 3, 9, 7, and 5 is an option. 3, 8, 7, and 6 is an option as well. But we know that, so we see that 7 has to go in this cage. But because of this 1, 7, 9 triple, there can't be a 7 in here, so there must be a 7 in here, removing this 7 and this 7. And there can't be a 9 in here, there can't be a 6. So we see that this is actually not an option because 7, 8, and 6 are impossible in those cells. So this must be ruled out. That's the correct one. And now 9 can't be in those cells, so it has to be a 3-5 pair. And we have 7 and 9 in those cells. But because of this 9, this is actually a 7, and that's a 9. This removes this 9 and this 7. And in turn, this 1-2 pair removes 1 from this cell and makes this a 1. Oh, there's a deadly pattern here, but this 3-7 will be disambiguated by this cage. Now, this 3-5 pair says that this is not a 5 and that there's no 5 in here, so the cage is actually 1, 8, 2, and 7. That's a 2, that's a 1, that's a 2, that's a 1, that's a 2, and now those are 1, 8, and 7. So 1 here, 8 here, 7 there, making this a 9, this a 7, this a 1, this a 9, a 7 here, no 7 here, an 8 up there, a 7, no 8 here, and I think that's it for this column. This 7 is not here, that's a 7. No 8 here, no 4 there, no 4 in this cell. Those must be 4 and 6. Making this a 5, this a 4. 3, 6, and 5. So 5 doesn't go here, this is a 6. And there's a 3-5 pair down there. Those are not, this 2 puts a 4 in here. And because of this cage, this becomes a 6. This is not a 9, it has to be 5, 6, or 8. And those digits must be 8 and 2 in some order. Note that if this is a 2, then the sum of this cage must be less than 20. Where should we look? This is still 4, 5, 8, or 9. And this one makes this a 6. And the remaining digits must be 2 and 7. They go this way. Now that's an 8, that's a 2. This is not an 8. This is not a 4, so that's a 9. And we have a 1 in this cell. This is 5, 4, or 8. Oh, why do I always say 5 instead of 4? And those cells, this can't be a 5 because of the cage. So it can't be, it could still be a 4, a 3, or an 8. And this one can't be an 8, so it has to be a 3, a 4, or a 5. Oh, now this one makes this a 4, so no 4 in this cell, and this a 1. Let's have a look at this. What are the options? Because the sum must obey the rule. So the options are 5, 9 plus 3, 7, or 8, 7, or 8, 3. What are the sums? First case, that's 24. 24 is valid. Second case is 29. 29 is not valid because there's a 9, not a 2. And last case is 25. It has a 5, but no 2. It's not valid. So the only possibility is 3 and 7, making this a 3. And now this 3, 7 deadly pattern is no longer deadly. And this 3 makes this a 5, this a 3, this not a 3, and this an 8, this not an 8. Let's have a look at this cage. We already have 18. So what could this be? It can't be a 4, an 8, or a 6. It could still be a 5 or nothing else. It can only be a 5. And the sum is 23, which is a valid sum for those digits. Now let's do some cleanup. So that's an 8, that's a 5, that's a 6, up there's a 5, that's a 6. So this is 8 or 9, that's a 3, that's a 5. We have a 3 here, 8 or 9, and a deadly pattern again. Let's have a look at this sum. We have 11 plus 8, that's 19, but 19 is not valid because we would have a 1 and not an 8. So there has to be a 9, and then the sum is 20, which is valid. So that's a correct solution. And this ends the solve of this all or nothing killer Sudoku puzzle that I set. Well, it was kind of challenging. I mean, I set it yesterday and I revised it today, and I still somewhat struggled to solve it. So thanks for watching this video, and see you soon on SudoKanard.